All right. What are we working on week 14 activity then?
Yeah. So I don't know exactly if I'm behind or not. I was just watching today. I was on week 14, day 2, and I just got done watching the videos.
Okay. I don't know if that's a day behind or not.
Yeah, I'm not sure. It might be.
Because I think, because today's Friday, yeah, I think it should be the last day in 14 day 3, but let me check real fast.
Maybe that one.
Yeah, so today is supposed to be so, but we can do day 2 if you want. I don't think it matters that much.
Okay. No.
Cool.
Mm-hmm. Yeah.
All right, let's see. So day 2 then.
Okay. Value here to
Cool.
just.
So we just have to complete these worksheets. Is that right?
Okay, so you on the mean value theorem?
The applications.
Yeah.
All right, we'll start with that one then. So states that if f of x is continuous on a closed interval a through b and differentiable on the open interval a to b, then at least one point on that interval where the slope of the tangent is equal to the slope of the secant, where the derivative is equal to the average rate of change between the endpoints. Okay, that's fair. It says use the mean value theorem to justify the following scenarios. So a trucker ended in a ticket at a toll booth showing that in 2 hours he had covered 159 miles on a toll road with a speed limit of 65 miles an hour. The trucker was cited for speeding. Why? Okay. So that's stating that in that 2 hour period, he must, at one point, he would have been going the average. And so we do 159 divided by 65. Sorry, divided by 2.
Divided by 2, and then.
It means at some point in that time, he must have been going almost 80 miles an hour.
Yeah.
Okay, that's fair.
Yeah. Okay. So that's all we say, right? It's just at some point.
Yeah.
The average speed.
Yeah. According to the mean value theorem, there was at least one point in time where he was going at least 79.5 miles an hour.
Okay. Okay. So the next one, marathoner run the 26.2 mile New York City Marathon in 2.2 hours. Show that at least I was running at exactly 11 miles per hour. The initial and final speeds are 0. So.
Okay, so we can find the average, 26.2 divided by 2.2. So that means that the average, there's the peak, I guess, there's 11.9. And so if she like speeds up and then goes back down, then there has to be a time before getting to 11.9 and a time after going to 11.9 that she was going exactly 11 miles per hour.
Okay.
So then the last thing it says, let f of x equal the absolute value of x minus 1. Show that there is no value of c that f of 3 minus f of 0 is equal to f of c times 3 minus 0. Okay. So f of 3 minus 0 is 3 minus 1, so that's 2. And then 0 minus 1 is 1. So you have 2 minus 1, which is equal to 1. So f of 3 minus f of 0 is equal to 1. And then equals f prime of c. Interesting. So oh, okay. So I think it's because the function isn't differentiable.
Yeah.
Because it's continuous but not differentiable.
Okay.
Interesting. So then there's let f of x equal plus 1 over x minus 1. Show that there is no value of c such as that f2 minus f0 equals of 2 minus 0. I think it's because the function is continuous at, it's discontinuous at x equals 1, which is between 2 and 0. And so it's non-differentiable over that period. So, cool. That's the first half. So then there's the other worksheet.
Emma, where did you put the charger? Okay. Everyone's been moving my stuff. Okay. Yeah, can you just bring it in here? Here, I'll talk after. Okay. So second half.
Right.
Okay.
So this next one, it talks about, says state the mean value theorem. Make sure you get all the conditions as well as the conclusion. Draw a picture that illustrates what the theorem says. So the mean value theorem, there's an interval on, it's like if there's a function on interval AB and differentiable on A through B, then there exists a point C that is between A and B, so that the rate of change in C is equal to the average rate of change from B to A, from A to B.
And then does it say that, or when the slope of the secant? So it's saying
What's that?
the secant line is the same as the tangent? Wait,
Yeah, so yeah, it's like
X.
its slope at that point is equal to the slope of the secant line.
Yeah.
So this is, let's call the secant line between the endpoints A and F of A and F of B. And we'll call it G of X. Find the equation of G of X. So, so the point is that would be A at A at F. Slope would be y2 minus y1 over x2 minus x1, or f of b minus f of a over b minus a. So that's the slope. And then you have the initial point. So it's, okay, they give us the equation. You have y minus y1. So f of a, oh no, y minus f of a is equal to the slope times x minus ax. So then we just subtract, sorry, we add f of a to both sides. That works.
Okay.
Cool, that makes sense.
So the next part, let's examine the vertical distance between x and g of x. Call the vertical distance between fx and g hx. The right-hand equation for h equals f of x minus g of x. So
Okay, so equation as before, except we do f of x minus the equation from before. It says now Rolle's theorem says that if a function is continuous on a through b, and the y values at the endpoints are equal, then there's a point C between a and b where the derivative is 0. Does h of x satisfy those conditions? So they're both continuous, so they satisfy the conditions. And then are the y values at the endpoints equal? H of a Yeah, h of a equals 0. Yeah, because if you plug in h of a, you get f of a minus f of a minus this mess times 0. And then if you plug in b, you get f of b minus f of a minus f of b minus f of a times b minus a, which you multiply that by the numerator, and then it actually just, yeah, it factors out, so it ends up being 0. So then, since h of x satisfies the conditions in Rolle's theorem, there must be a point C between a and b where the zero. Because if h of a is 0 and b of a is 0, it's almost like a parabolic shape. So there's one point in the middle or somewhere that there is that it hits its peak. So then h prime of x constant okay. So it's f there's a constant, and that's a constant times x. Okay, so you just end up with the f prime of x minus f of b minus f of a over b minus a. And if you plug c into h prime and set it equal to 0, we can get h prime of 0 . So we have f prime of c, fb minus fa over b minus a. So if that equals 0, then it means that the derivative of f at c is equal to f of b minus f of a over b minus a. And that's the mean value theorem. Cool. So I think that was it. Anything else? Any questions about the mean value theorem?
I don't think so. I think it makes sense.
Cool. Yeah, just go ahead and send me the link, and
Okay.
I think that's that. I think that was the last group meeting too. Good luck with the final.
Yeah, you too.
All right. See you later.